So we said we'll do a few problems from base. So let's get started with some easy problems. Then we can go to some medium. Okay. Again, we didn't do Doppler effect well for you, but we will do some problems based on what we discussed. Okay, let's see. First one, it says spring of mass 2.5 kg under tension of 200 Newton. The length of the stretch string is 20 meter. If the transverse jerk is struck at one end of the string, how long does the distance take to reach the other end? So they're asking you to find the time taken for long. So if I want to find the time, I need to find the velocity. If I know the velocity or the speed, then based on the distance, I can calculate the time. So I think they indirectly asked you to calculate the speed. So I'll give you some simple methods quickly, so we can try it based on the formulas. So we studied some formula from your handbook. So let's see. Okay, so we're talking about this transverse waves. It's the string of mass is under the tension. That is the string. So transverse, so it's like a transverse wave. So which means I need to be using this one. So tension is given. Tension is given. They are given the length of the string and then they are given the mass. What is mu? Mu is linear density. What do you mean by linear density? Mass by length. So mass is 2.5 kg divided by length is 20 meters. So do the math, you'll be getting 0.125 kg per meter. right? So it means you know the mu. If you do the math, you'll be getting the velocity. But you know velocity is equal to distance by time. So distance of the string, length of the string is given. So this much. They're asking you to find the time taken. So that means if you find the V from this formula, you know V and then you can find the T. Is that okay, Ashwin? Following?
Yes, sir.
So I'm just teaching you some easy problems so that it's easy for you to do it in the exam. Okay, again, multiplication division, it's your department. Okay, I'm not going to spend time doing multiplication division. A stone dropped from the top of a tower of height 300 meters splashes into the water of a pond near the base of the tower. When is the splash heard at the top, given that the speed of the sound in air is 340 meters per second? So that means, let's assume that you are standing in this tower and there is a pond over here. So you are standing here and then you are dropping a ball from here. Stone dropped from 300-meter height splashes into the water of a pond near the base of the tower. When is the splash here? So it means we have to calculate the time taken for the stone to reach here. So that is I'm going to take as time t1, and then the sound wave has to travel back over here. So it's going to hit the water, and then you are going to see the sound wave traveling in this. Do you agree?
Can you repeat it, sir?
Hmm?
So can you just repeat it, sir? I didn't-
When the stone is dropped, right? The stone takes few seconds for it to reach to the bottom of the ground. Do you agree?
Yes, sir.
So that is taken as time t1. Now after the stone hits the water, the splash is not immediately here. The sound wave has to travel to the top of the tower. That means that time I'm going to take this t2. Okay.
Okay.
So total time taken is what they are asked. So total time will be t1 plus t2. So how long does it take? The stone is dropped, which means initial velocity is 0. So S is equal to ut plus half at square. I need to find the time. So v square is equal to d square divided by 4. So S is equal to ut plus half at square. So initial velocity is 0 because the stone is dropped. Okay, which means this is 0. So the displacement is 300 meters. Half gt square. So g is 9.8 of 10. T squared is t1. That means everything t1. So this 0 and this 0 will cancel. This 2 comes on this side, so it becomes 16. So t1 squared is equal to 16. So t1 is equal to root of 16. 49 is 7, 8 is 64. So 7 point something, right? So this must be 7 point some value. Now I'm going to calculate the time taken for it to the sound wave to try reach from here to here, right? So the sound is traveling to here. Speed of sound is given as 340 meters per second. So velocity is equal to distance by time. So velocity is 340. Distance is 300 meters. Time taken is t2. So t2 is equal to 0, 0 cancels. So 30 by 34. that many seconds, which is less than 1. So I think this will be something like 0.8 or 0.9, I do not know. So we have to add this and this, and then you have to tell the total time. Is that okay, Ashwant? Can you do the math yourself?
Yes, sir.
Of course, you can check that, double check your answer with the textbook answer, the solution. Okay, let's go to the next one. Steel wire has a length of 12 meter and a mass of 2.1 kg. What should be the tension in the wire so that the speed of a transverse wave on the wire equals the speed of sound in dry air? Just now we studied a formula, V is equal to root of tension by mu. Mu is, they given it as mass by length. So mass is 2.1 kg divided by length is 12. So do this math and find out the mu. Tension is what is asked. So that means this is asked. Velocity they are given as 340. That's all. So do squaring on both sides and find out the t. Is that okay? Vishwant, I'm talking to you.
Yes, sir.
Use the formula V is equal to gamma P by rho, which is your Laplace correction, right? Corrected formula. Newton's formula, you will have only P by rho, area gamma. To explain why the speed of sound in air is independent of pressure, increases with temperature, increases with humidity. Okay, so I think we talked about this in theory, so let's talk about that also. The handbook I given it here, so I think it's in that here. As the pressure, so the first one is easy. As the pressure increases, the density will also increase correspondingly, which means both will cancel. So the increase will be corresponding increase, which means this is kind of independent of pressure. Even though the formula looks like it's dependent on pressure, as pressure increases, density will also increase. Because you can think of PV is equal to mu or T. So assuming the temperature is same, right? Suppose if I'm increasing this value, so this will be PV is equal to MRST. So P is equal to, when the volume comes on this side, mass by volume, RST. I said we are keeping the temperature same, RS is a gas specific constant, mass by volume is density, so P is equal to rho RST. So what this tells you is pressure and rho are in the same order, right? It's not like square or cube or something like that, which means it's linear, directly proportional. So because of this, what will happen is when P increases, rho will also increase proportionally. So V remains the same. So V is independent of pressure. Okay. Second one is increases with temperature. Let's see how I can explain that. In place of P, I can put rho RST, right? So that means I can say V is equal to gamma. In place of P, I'm going to put rho RST. In the denominator, I already have rho density. So rho cancels. So I'll be getting gamma RS. What this means is velocity is proportional to the square root of temperature. So as temperature increases, velocity will also increase. Sorry, as T increases, V will increase. Is that okay? Following?
Yes, sir.
Any difficulty here? So where do I get this RS? This gigantic theory properly.
Sir, understood.
Okay. Increases with humidity. We don't have much of formulas for humidity. But what I can simply say is this is more like a qualitative explanation. So what we can say is as humidity increases, what will happen is some of the oxygen and nitrogen molecules will be replaced with water molecules. They are. So if I add, some of the oxygen, nitrogen is removed and hydrogen, H2O is added, water molecules are added in the vapor form. So if that is the case, what happens is the humidity actually decreases. Okay, so since the humidity, the humidity increases. So if the humidity increases, the density decreases. Because some of the molecules have been replaced with water molecules. So the amount of oxygen nitrogen molecules will be less, for example, in the case of here. So when density decreases, right, from this formula, you can say if this value decreases, then you can say that this value will increase. And so density decreases, V increases. Okay, let's see. Okay, what will be the next one? We want that a traveling wave on one dimension is represented by a function of t. Function y is a function of x and t, where x and t must appear in the combination x plus vt, x plus vt, x plus n minus vt. Okay. Is a converse to examine if the following functions for y can possibly represent the traveling wave. Okay, so the explanation here is a little bit mathematical, just like what I said in the oscillations chapter. So, for example, log, I cannot find a value when x is equal to 0. Time t is equal to 0. So, when x is equal to 0 and time t is equal to 0, this will become 0. So, log 0 is undefined from your mathematics, right? So log 0 is undefined. Similarly, if I put x is equal to 0 and t is equal to 0, 1 by 0 is undefined. So for this reason, I cannot have these two kind of waves. These two cannot represent the waves. X minus vt the whole square. X is equal to 0, t is equal to 0 means it is defined. Okay. X minus vt should be x minus vt the whole square should be included. The answer is confusing. It says remaining functions and new function C satisfies this condition. Okay, I think there is some floating error or something. Yes. Interesting. So I think only A will be the correct answer because C is also undefined, B is also undefined, and x is equal to 0, t is equal to 0. Okay, let's see. Point C6 is the easy one, so let's quickly do that. Bat emits ultrasonic sound of frequency 1000 kHz in air. If the sound meets the water surface, what is the wavelength of the reflected sound, transmitted sound, the speed of sound in air? Okay, so you have some water surface here. You have a bat over here. So it is giving out some sound wave. It's getting reflected back. And some of the sound is kind of transmitted. So this is your reflected. This is your transmitted. What is the wavelength of the reflected sound? So the wavelength is not going to change in the case of reflection. So it's going to be the same. Only when it is passing through another medium, right? It will change. V is equal to nu lambda. So I'm talking about in the air, and this will be in the water. So velocity of the sound in air is given. Frequency in the air is given, right? Which means I can find the lambda. Similarly, I'm going to write for velocity in water. It's also given. Nu in water, lambda in water. The frequency does not change in different mediums, so the frequency will be the same. Is that okay, Vishwan?
Yes, sir.
We'll study more about this, okay, in the 12th standard. So when it is passing, when the light is passing from air to glass, the frequency remains the same, but the wavelength alone will change. So it's the same thing in sound waves also. So this is changing. So you see 1486. Speed changes, the frequency remains the same. So the frequency will be 1000 kilohertz. Which means you can find the lambda. So copy it, very easy problems. Okay, if you get this in the exams, it will be easily you can score marks. Copy.
Copies. Copies.
Okay. Hospital uses an ultrasonic scanner to locate tumors in a tissue. What is the wavelength of sound in the tissue in which the speed of sound is 1.7 kilometers per second? Operating frequency of the scanner is 4.2 megahertz. Okay, very simple. So simply use the same formula. So V is equal to nu lambda. So velocity is given, frequency is given, which means lambda can be found. Is that okay? Okay, not okay.
Okay, sir.
transverse harmonic wave on string is described by y x comma t is equal to 3 sine omega t plus so sine omega t plus kx with phase angle. So you know that this is omega t, this is kx, this is initial angle phase phi, this is amplitude a. X and y, they said it is in centimeters, t is in seconds. The positive direction of x is from the left to right, which means this is positive to right. Is this a traveling wave or a stationary wave? So let's go back to our basics. So standing wave means the equation will look slightly different. So let's look into that. Yeah, so standing wave means it should be looking something like this: 2a sine kx cos omega t. But here we are seeing a pattern which is sine omega t plus kx, which is something like this. So this is more like a progressive wave. This is like a standing wave. So you can see the pattern does not look like this, it's looking like this. So since it is looking like this, I would say it's a progressive wave, a traveling wave. If it is traveling, what are the speed and direction of its propagation? Well, we said, when you say kx minus omega t, here it is plus omega t. So if it is, should be going here. So if the wave is going this way, right, it should be minus omega t. The wave is coming like this, it should be plus omega t. So since I am seeing a plus omega t, I think the direction I will say it as right to left. What are its amplitude? Amplitude is easy, 3. Frequency is coming from omega, so that means 2 pi nu. Omega is equal to 2 pi nu. Omega is 36. That means nu can be found from this. So 36 by 2 pi will give me the frequency. What is the initial phase of the origin? So initial phase is this one. So this is your initial phase. What is the least distance between two successive crests in the wave? So two successive crests and troughs. So peaks are called the crests. So that means the minimum distance means it's a wavelength. So instead of asking it as wavelength, they are asking you indirectly. So what is the least distance between two successive crests? So how do I calculate lambda? So this is k. So k is equal to 2 pi by lambda. So lambda is equal to 2 pi by k. So 2 pi by k. K is 0.019. That many centimeters. So do the math and get the answer. This will be 6 point something. So this will cancel. So 0.03 and 0.003. So Okay, now you can do the division. Following everything? Okay, as I told you, we have been doing some easy ones, so let's see. I think after this, probably it will become slightly medium difficult. The wave described in 15.8 plot the displacement y versus t graphs. So this is like what are the shapes of these graphs? So in which aspect does the oscillator motion traveling wave differ from one point to the amplitude frequency of this? We differ by phase, right? So when you have a wave like this, so there is a phase difference between this point and this point, but the amplitude will reach the same point. So after some time, this particle will also reach this point. So it means amplitude will be the same. Frequency will be oscillating in the same frequency. That means this will be the same. So only the phase, there is a phase difference between this and this. So it means you should say that there is an angle difference between this point and this point. So that is what we call as phase difference. Okay, so that's the answer for the last part. What are the shapes of these graphs? I think you need to do like different locations have to be found, right? So x is equal to 0, 1, 2, 3, 4. So you need to plot at least 4 or 5 points. And then you have to plot it for different time instance. So something like t is equal to 1, t is equal to 2. They didn't give you the time instance, no what time instance. Maybe you are supposed to find the okay, so this cannot be done manually, so you have to do some kind of algorithm simulation. So for now, I'll skip this. Frequency would have found it from here. So in 1 second, how many cycles are happening? So you can also find the time period. So omega is equal to 2 pi by t. So t is equal to 2 pi by omega. So 2 pi divided by omega. Omega is 36. It's pi by 18. So 6. I think we may have to plot, when they ask you to plot, we may have to plot it for one full time period. Okay, so what the rates? So pi by 18 will come as 3.14 divided by 8. Zero point 174. Which means to say that you may have to plot it for different time instance, such as 0.1 seconds, 0.2, 0.05 seconds, 0.1 seconds, 0.15 seconds, or something. Okay, for now I would say skip this because it involves some computer simulations. Only then you will be able to solve it. The traveling harmonic wave is equal to this. So 2 cos tan x and y are in centimeters. So I'm supposed to find the phase difference. So phase difference between 2 points spread by distance of lambda. So for lambda it is 2 pi. How much it is for this distance? 4 meters. So that will be the first one. Which means if I find the lambda, I'm done. So that means this is omega t. This is kx. So k is equal to 2 pi by lambda. So lambda is equal to 2 pi by k. So k is 0.00. This two cancel, so I'll be getting so 0.03. That many radians. Let's see if I'm making any mistakes here. They said this is in meters, sorry, centimeters. So I think I see meters. This is centimeters. So centimeters. I think this will be in meters. This means 2 pi by lambda. So the lambda should also be in meters. But then x is in centimeters, so it means lambda is also in centimeters. Okay, so I made a mistake. So lambda is in centimeters, and this will also be in centimeters. And this will be into 400 because I have to take it in centimeters. This will be multiplied by 2 zeros, so it will be 3.2 radians. Any step which is not clear? It's not matching with the book lines. Okay, the mistake I have done is I did not consider this 2 pi. Okay, so I took only this one. So this 2 pi should be multiplied inside this. It's in place of k, it is actually 2 pi. 2 pi cancels. So what is left is only this much. So lambda. So do the math. It will be 3.2 into 2 pi. 3.2 into 2 pi. 6.4 pi. So let's secret answer. After this, it's the same method. Okay, so in place of 4 meter, you have to put 0.5 meters. In place of lambda, you should put lambda by 2. Right? Lambda cancels, or 3 lambda by 4. So follow the same method, we should get the answers.
Okay.
This you can do it in common sense. So right yourself. You have difficulty, you can check. This is also something very similar. Okay. Yeah, this is something very similar to what we did earlier, right? So traveling wave or stationary wave. So when you see sine and cos, right, it appears to me that it is like a standing wave. So let me go back to the handbook. You see, if you have sine kx cos omega t, if you see something like that, then it is a standing wave. So sine kx plus cos omega t. So it means it's a standing wave. Is that okay?
Yes, sir.
Sine kx cos omega t. So when you get an equation like this, it is a standing wave. Interpret the wave as a superposition of two waves traveling in opposite directions. What is the wavelength, frequency, and speed of each wave? Again, you have to go back to the basics. So we said the initial incidence angle is incident wave is A sine kx minus omega t. Y r reflected, we said sine, it will be coming back, which means kx plus omega t. So I already explained it. I given some diagrams in the handbook, so then take a look at it. So the standing wave is nothing but incident plus reflected, which means according to the formula which we studied, C plus d by 2, C minus d by 2. So C plus d by 2 means this and this will cancel. So I'll be getting 2kx divided by 2. So 2 cancels. So that means I'll be getting A sine, and then there will be a 2 here, 2A sine kx. And this minus this term will cancel, which whereas this term will add up. So that means cos omega t. Actually, you'll get a minus omega t, but cos minus theta is equal to plus theta, cos theta. So that means you can right click this. So what is given here in this equation is 0.06 sine kx. So in place of k, you have that 2 pi by 3 cos 120 pi. So in place of k, you have this. In place of omega, you have this. In place of 2a, you have this. Which means you can say amplitude is equal to 0.03 meters. Read the question one more time. They're asking you interpret the wave as a superposition of two waves traveling in opposite directions. What is the wavelength, frequency, and speed of each wave? So amplitude we have found out. They didn't ask you the amplitude. They're asking you to find the frequency, wavelength, and speed of each wave. So I can say omega frequency can be found as omega is equal to 120 pi. Omega is nothing but 2 pi nu. 120 pi, which means pi cancels, 2 and this cancels. So it will be 60. So mu is equal to 60 plus. Wavelength, you can use this formula. So k is equal to 2 pi by lambda. So lambda is equal to k is equal to 2 pi by 3. Means lambda is equal to 3 meters. Okay, so this is okay. This is okay. Then I'm supposed to find the velocity. How to find the velocity? We studied the formula v is equal to omega by k. Why omega by k? Because we studied omega is equal to 2 pi by t. Then k is 2 pi by lambda. So when lambda goes to the top, 2 pi cancels. So lambda by t is nothing but distance by time. Distance by time is nothing but velocity. So because of this reason, I'll be writing this as 2 pi by t can be written as omega. 2 pi by lambda can be written as k. So since I know the value for omega and k, I can simply substitute. So omega is 120 pi. This is 2 pi by 3. So pi cancels. This and this cancels. So 60 into 3, 3 goes to the top. So 1. Okay, so that's all for the B part. Okay, so we found the velocity also. That was the last part. think they're asking you to find the tension. Determine the tension in the string. So we have been using the same formula again and again. So you know that the string length is given, mass is given. So it means I can say tension is equal to, velocity is equal to square root of tension divided by mu. So mu is equal to mass by length. So mass is given, length is given, which means you can find the mu, which means mu is wrong. Velocity just now we calculated it. So if I know the velocity, I can calculate the tension. So multiplication division is your department. Is that okay, Ashwant?
Yes, sir.
Okay. Okay, so I think we have done up to 11th one. Some of the topics which we didn't do, we can skip it. Okay, so the Doppler effect problems, you can skip it.
Okay, sir.
Frequency. Next class, are you planning to attend or not?
Sir, I guess I won't be attending next class, sir.
The exams are starting. Okay.
Yes, sir.
Okay, then I would say good luck for your exams. Okay.
Thanks.
So go back and study this. Okay, the Doppler effect problems, I think it's not there in the syllabus for now. You can skip those Doppler effect problems. All the basic ones which we studied right now, you can study it again. Okay.
Okay, sir.
These problems you can try it. If you have difficulty, you send me a message. Okay. So we can do it. Is it okay?
Okay, sir.
Okay. Thank you. Bye then.
Thank you, sir.